Well, the Apple computer.
What was the notification?
You can easily tell it's an Apple computer because all the system notification sounds by default, they're all completely different from Windows or even Linux.
Yeah.
If you guys have watched WALL-E, the movie.
Oh yeah.
Yeah, when WALL-E rebooted, it made the same sound as a Mac. Yeah, that's really cute because it traces its root, back to Pixar, which is owned by or started by Steve Jobs.
Oh.
Which is the
Yeah.
the
Probably the
CEO
father
of
yeah.
Apple Computer.
Yeah.
So that's it's interesting. That movie has a lot of content that won't be understood by kids, but people in their at least 20s or 30s would go like, yeah, I remember that, or I recognize that. Like Otto, the antagonist. You remember Otto, the red dot thing, is controlling everything.
Oh, yeah.
That's actually inspired by HAL 9000
yeah.
from
Yeah.
2001: The Space Odyssey. Yep. Which is also a very good sci-fi. Even by today's standard, it is a very good sci-fi. All right. So we'll start today's class by, we'll talk a little bit about the unified modeling language, and then we'll go back to the homework assignment because I want to disclose, what I would do, for the homework assignment. The unified modeling language is not mentioned in the textbook, but the textbook did mention systems analysis and all the other aspects of programming. And I think it really should mention the unified modeling language. It has been around for a long, long time, since 1997. And the reason why we have the UML is because we need a universal language for all different systems administrators, system analysts, programmers, system testers, and whatnot, to have the same common language to understand the system specification. Okay, the system specification serves the same purpose as a blueprint when it comes to building a house. Did I talk about building a house and the blueprint earlier in this class? I don't think so. I think we skipped over that topic earlier.
Lego and all that compared to Scratch, the Lego. Remember?
Yeah. Lego Mindstorms.
Lego Mindstorms.
Lego Mindstorms. But this goes beyond that. This goes a little bit beyond that. So let's kind of go back a little bit and think about software systems analysts, and the client, people who are actually going to use the system or want to specify the system. We'll start with building a house. All right. In other words, let's forget this is a class about programming, about computer science and stuff like that. Let's think about building a house. Let's just say that for some reason you inherit a piece of land that is on the coast of California along Highway 1. So it's kind of like a cliff overseeing the Pacific Ocean. It's a really nice piece of a property. Except there's no property. There's only the land, but the lot, but not a property. So now you can build a house. And for whatever strange reason, you also have basically an unlimited budget to build that house. Okay, so money is not a factor. Okay, so we can keep dreaming on. It becomes a fantasy at this point. Okay, so now you want to build a house. It has very nice scenery. So what are you gonna do? What is the first step? I like camping. I don't want to build a house. Let's just bypass the building of the house. And be done with it. Okay, but let's just say that you want to build a house. Okay, what would be the process of building a house? The land is yours already, so we have the resources already allocated. So what is the first step of building your dream house?
Design.
Design, very good. So who would you hire to design the house? The best contractors around the area? Yeah, the contractors are not for designing a house. The contractors, are for carrying out the plan to build a house. So they're really good at doing that, building, but they're not, necessarily the best people to, to ask when you want to design a house. How do we call those people? People who actually design the house. Architects, very good. Can anyone name a famous architect in the past, decade or so?
Oh, dead.
Yeah, a dead one.
No, I was thinking like Leonardo.
Do you guys know what is the building? I cannot even remember the architect's name. I think Lloyd is a part of the name.
Right.
Yep. Architect. architect Lloyd. There we go. Frank Lloyd Wright. Now he's really famous for many, many reasons, but when you look for images, built houses that he has built, this is one of the most famous house that he has designed. It's called something over water. It's basically a house built over a natural waterfall. So when you go to the lowest floor of the entire house, there you have it. The actual waterfall is actually at the quote unquote basement of the house. So it's kind of nice because when you look out from the house, you're looking out into the I guess it's a stream. I probably won't build a house over the Viagra or anything that is too big, But he is famous for designing the house. Okay, so now you have the architect. What are you going to do with the architect? You're the client. You are the person who is going to live in the house. So what do you want to do with your architect? Just kind of turn him loose or turn her loose and go, okay, just design something that's wild, I can pay you. Yep.
Tell him what you want.
Tell him or her what you want. Okay, so what would that include? What you want as a client. You're going to be living in the house. So what do you want? What kind of
walls?
Okay,
How many
what?
rooms?
How many rooms? Okay, very good. So we'll start with how many rooms and how big the house is going to be.
How many
Do you want to
stories?
end? Sorry?
Like how many stories?
How many stories? Now, how many stories is kind of technical, so maybe you don't need to convey that to the architect, but you have more basic requirements. Like, how many rooms is one, okay? If you like to entertain guests, you might need more bedrooms. Or if you prefer to be more private, you just need 2 or 3 rooms. Maybe a good, studio if you are an artist, okay? You want to have a sunlit, naturally lit, studio that oversees, the Pacific Ocean. That can be inspiring. Unless there's a storm. Well, actually, in a storm, it's even more inspiring.
So
It
it
inspires
doesn't kill you.
fear. What else? What else? You have a house. You have a lot
Furnishings.
that is next to the Pacific Ocean.
Furnishings and
Furnishings. Now, furnishing is not the job of an architect.
No.
So the architect is, unless it's integrated into the building itself. What about the patio? Don't you think there are all kinds of possibilities with the patio? When your house is at a cliff and is overseeing the Pacific Ocean.
Backyard.
Okay, the backyard. Okay, so you might want to have certain requirements of the backyard, like it has to be open. And maybe the patio can extend out of the cliff a little bit. Okay, with a transparent bottom. Okay, so on a calm day, you can walk over the patio and actually look down
You can
and
blindfold
actually
your
see the
friends.
waves crashing onto the rocks. Those are requirements. Okay, that's what you want, so that you can enjoy your house. You might want to make it a 2 or 3 car garage, depending on whether you want to collect cars or whether you consider your cars just a means of transportation. So you just need 1 or 2. Okay, so that's also a requirement. Okay, depending on your preferences and your needs. Okay. You might want to tell the architect, which way the windows, want to face. If you like to wake up in the morning with natural sunlight, then you need your bedroom windows to be facing east, which means it's not going to be facing the Pacific Ocean. Unless, you have an entire floor that is your bedroom, so you can have windows both facing east and west. Okay. You might want to think about entertainment. Okay, not for guests, but also for yourself. You might want to have an entertainment room where there's no window, or if it does have window, it can all be closed, so you can enjoy your games and stuff.
Like a man cave.
Yeah, man cave. Yep, exactly. Okay. So there are all kinds of requirements they can convey to the architect. But do you tell the architect that, oh, you know what? I think I would like to have this room shaped like this and stuff like that? Unless you have a very specific requirement, you probably just want to leave it to the architect to design the details. Okay, where do you want to put the faucet? Do you want to specify that, or do you want to just let the architect do the job? You probably just want to let the architect do the job. Okay. All right. So that's the job of an architect. So after the first draft of the architect's work, what do you do? You sit down with the architect, you go over, the design, which is on the blueprint, okay? These days it's on a computer, but nonetheless, it is quote unquote a blueprint. You go over the design, and then the architect these days, they have 3D modeling, so you can actually walk through the house without the house being built. They can even get the lightings and the exterior view, everything done correctly now with computer 3D modeling. So you can actually walk through the house and actually see what you should be seeing out of the house, like the Pacific Ocean and stuff like that. All right. So if you don't like certain particular aspects of the house, you can go back to the architect and say, well, I think this part, I think we can change it a little bit. Maybe add one more bay to the garage, maybe making the bedroom a little bit bigger or smaller, adding one more guest room, a study, maybe a library if you want, and stuff like that. So after a few rounds, you and the architect will agree and say, okay, this is the kind of house that I want to build, right? With a patio extending over the cliff, and stuff like that, all kinds of fancy features. What do you do next?
Get a contractor.
Not yet, okay? There's a very important person you need to hire. Yep.
Oh, I'm sorry. I thought you need to go to get a permit.
You need to get a permit. Okay, that's related to getting a permit. But before you can get a permit, who do you need to contact?
Contractor.
Nope, not contractor.
Supervisor?
Sorry?
Supervisor?
Supervisor?
Real
No.
estate agent.
No, that person is called an engineer.
An engineer.
An engineer, and a civil engineer at that. Okay, so a civil engineer is an engineer, and as any engineer, a civil engineer knows everything about physics, forces, what type of material to use, the strength of material, how to evaluate the cliff for stability. Okay, how to reinforce something so it is strong enough to do whatever you need to do. So the engineer will go over the blueprint and then say, okay, I think this design may have some problems because the cliff may not be strong enough to support the patio. Okay, so for technical reasons, some aspects of the house may need to be changed. Okay, to make it feasible and safe. Okay, and also make it compliant to all the different codes, because there may be certain code that require you to build a house in a certain way. So that's the job of an engineer, basically taking care of the technical details so that the house is feasible and safe. All right? So right now we have 3 parties already. We have you, the client, the person who will live in the house and want to specify how the house should be, all the requirements and stuff like that, but don't really quite know how to design it or to get it built. We have the architect, who is a person who can design the house according to your requirements, but doesn't have the technical know-how to make sure the house can be built safely and according to all the requirements. And then we have the third person, the third party, which is the engineer. The engineer probably is not a very creative person, but he or she can go over the blueprint and go through all the tests to assess the quality of the soil, and make sure that the house can be built safely on that lot. Okay. Only after this process is done, you can get a permit. After you get a permit, then what do? Now you get the contractors. Okay. Now you get the contractors. So the contractors will come in, but how do you know the contractors know exactly how to build a house?
You know the blueprint?
The blueprint, all right. So it sounds like the blueprint is very important, right? Okay, this is the document that starts from the very beginning so that the architect can communicate with you, what it will look like, so that you can approve the preliminary design. The engineer will take the blueprint and make sure that everything works out in terms of calculations and compliance. And now the contractors will come in and use the blueprint for building purposes. Okay? So the contractors will spend, a few months at least, to build a house. And then after the contractors are done, what else do you need to do with that house? Just move in, right? You cannot just move in yet. What else do you need to do? That's one more person. Inspection, very good, exactly. So the county or the city, and probably you want to hire an independent inspector just to make sure that the house is built to specification. So the inspector will also use the blueprint and go over the features of the house one by one to make sure that the house is built to specification. Okay, and only after that the house is ready to be lived in. And then after you live in the house, who do you need?
Electricity.
Electricity, but what type of people or service do you need after you move into the house? There is that. But
Illustrations.
Extreme makeover people.
extreme makeover people.
Including
You
that,
need
right?
people who help you maintain the house. Okay, every few years or so, you need someone to paint the house, especially because it is right next to the Pacific Ocean. It probably needs to be painted a little bit more frequently compared to Sacramento. You need people to take care of the landscape, right? Okay. So depending on what you want for the landscape, maybe someone has to come in every week, every 2 weeks, or if you prefer a more natural look, someone can come in every 6 months or so to trim the trees and stuff like that. So you need ongoing maintenance, okay? Ongoing maintenance people to help you maintain the house so it remains, safe and operational. Okay. So now we can change our attention or shift our attention from a house to a computer system. We're not talking about a single program. We're not talking about a single application program like Microsoft Word or something like that. We're talking about an entire information system. When we talk about an information system, we're talking about, let's say, the information system or the computer system of Wells Fargo Bank. Okay, that's an information system. It is consisting of a lot of hardware, software, and also people in the process. But it actually has the same elements or the same steps as what we have just mentioned. It's just applied differently. Who's the client? Who's the person, quote unquote, living in the house? The house is now the information system. Okay, so who is going to specify? Oh, I want this house to have 5 rooms and da 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 da.
The information itself.
The organization itself, and instead of saying we need 5 rooms and stuff like that, what do you think that organization, or let's say we're talking about Wells Fargo Bank. Okay, so what do you think the corporation will tell? What kind of requirements they have? What do they want to specify?
Secure.
Sorry?
Secure.
Security, okay, it has to be secure. So there may be standards in security. So they will have to say the system has to pass all of these tests in terms of security. Very good. What else?
Managing resources.
Managing resources. What do you mean by that?
Like they run the company, they organize how the company is used and where it goes to.
Okay, well that's kind of a little bit more to the detail side, so maybe that can be determined later. Maybe Wells Fargo Bank has a requirement of customer satisfaction. In other words, they want to make sure that every time you click a link on their website, it has to respond within 1 second. Okay, whatever amount of time, but they will have a requirement and say that I don't want our customers to be fed up because the website is too slow. Okay. Another requirement, very common to banks and online merchants, is availability. In other words, it's related to reliability, but it's also not exactly the same thing. You can have a system that is extremely reliable, but without a whole lot of availability. In other words, you can set up a system where it's only operational 1 hour every day, but during that 1 hour, it's bulletproof. But it will be down for another 23 hours before it's up again. So that's a system that is reliable, bulletproof, but not very available. Availability means the system has to be up 24/7, 365. And right now is a good test of such systems because systems that are not like that, with the East Coast, the storm and the East Coast going, a lot of websites are actually getting impacted. The really funny thing, or the really ironic fact is the IEEE website is affected. Now the IEEE, let me bring you to the website so you can see for yourself what it means, why I think it is ironic. IEEE stands for International Electrical Engineer something. I cannot remember the full name. Okay, so you can click about IEEE. It doesn't say anything about, I guess Wikipedia will probably find the definition of IEEE faster than IEEE's own website. Okay.
Simulation.
Let's go.
Engineers.
Okay, engineers, electrical and electronic engineers. So IEEE stands for the Institute, not the Institute of Electrical and Electronics Engineers, which means geeks. Okay, for to be short, this means geeks. When you get your degree in computer science, you probably want to join the IEEE, as an organization, because the membership really says something about what you're good at and stuff like that. But look at this update here, Hurricane Sandy update. The effects of Hurricane Sandy are profound throughout the eastern seaboard, blah, 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 blah. And the most important part is some of its services are down because of that. So we have a website designed for high-tech, geeks, and yet it is not, it is affected by the storm, okay, which is only happening to one part of the country. What is that telling you? They may know everything about transistors, how to make a smaller transistor, how the physics works, but they probably have very little idea of how to make their system robust. That's, and that means, on one hand, you have people who may be very good. You're working for Intel and AMD, to make the latest and greatest processors. Because I will bet you, about 99% of those engineers are members of the IEEE. And if you look at, the leadership of IEEE, they are all, well-published, top-ranking researchers. But when you look at, how they manage their website, they could have done a better job. I think they could have done a better job using virtual machines and putting everything in the cloud so that it is not as susceptible to, basically, a particular country, getting, impacted by the storm should have no impacts whatsoever to the website. Can you imagine Amazon.com, has to shut down, or some parts of Amazon.com would stop working because of the storm?
Like the cancel button.
Like cancel button.
The whole code for the cancel button was
Everything is one click, right? Oh,
You have
you
to
click
go
it, you
forward.
order it. You click it, you order it.
How did I spend $5 million in Amazon.com?
Yeah.
sticky clicker button.
Yeah, the entire FedEx freight truck is at the
For
door.
you.
It's like, oh, it's all yours.
Same thing, dude. You got a lot of toasters in here.
Yep. All right. Well, in that case, you have a helicopter hovering over your house.
Asking for toast.
Yep. So anyway, we were talking about what? Availability. Okay. So the IEEE website, has limited availability, and they did not take into account, how a big storm, only at one portion of the country can impact, its services. All right. So that's another requirement. What else? What else may be, requirements that can be vague? It doesn't have to be very technical and have numbers. How about easy to use? Ease of use, from the customer's perspective. Now, there's no really, there's no index or gauge to say, oh, this system, has an ease of use, factor of, 200 out of, 300. There are no such thing, in place that I know of that can evaluate the user friendliness. But that can still be a requirement. You can still say that I want this website to be, user friendly, both to end users and also to people inside the bank, who have to use the system internally. So there are all these requirements that Wells Fargo Bank may want to specify and say that this system has to fulfill all these requirements. Okay, they can be vague, they can be specific. It doesn't matter. Okay, there are still requirements. So now the next person Wells Fargo Bank has to contact is quote unquote the architect. But the architect in this case is called a systems analyst. Okay, so a systems analyst takes the place of an architect in an information system design and take all these requirements in and then start to work on the design. Okay? So the design may involve, okay, let's, I think we need, this type of program in place, that type of hardware in place, and so on and so forth. But there is one thing that makes the systems analyst very different from an architect. The systems analyst also has to specify the behavior of the system in addition to other parameters. In other words, the systems analyst is also responsible to specify, when a user try to log in 3 consecutive times from the same IP address in 1 hour, we need to lock out the account. That has to be specified by the architect or the systems analyst in this case. And instead of putting everything in a blueprint, which is a visual plan of a house, everything is now put into documents. Okay? And that's exactly why we have to talk about the UML, because this is the blueprint language used by information system design. And that's basically a somewhat universal language or specification for a lot of different organizations to use. It will be very helpful if you know what it is and how to use it by the time you graduate from a 4-year university. It's not as important here at a 2-year college, but at a 4-year university, I think it will be very helpful if you can tell your potential employer and say, I know how to use the UML. I know how to read it, and I know how to edit documents, and I know how to create documents using the UML. I think that will be very useful. Okay, so that's basically what it is. And we'll continue to talk about the equivalence of all the other people, like the engineers, the contractors, the inspector, and so on, the maintainers, like the landscape people. We'll talk about that later. Okay, so right here you can see the description in Wikipedia. The UML is used to specify, visualize, modify, construct, and document the artifacts of an object-oriented software-intensive system under development. That's a mouthful. It's basically a language for the specification of an information system. That's basically what it is. It offers a standard way to visualize a system's architectural blueprints. Remember, I talked about architecture and also blueprint. That's exactly the same terms that it's using. And by the way, I didn't read this before the class, so we just kind of accidentally decided to use the same terms. Now the elements they can be a little bit confusing, and there's no way we can go over all of these different elements. These so-called elements are basically different aspects of an information system. So in the analogy of building a house, you basically have one picture to document the wiring, the electrical wiring, another picture maybe to show the ducting, of the AC system, maybe another one to outline the security system. So these serve different purposes. We'll go over activities. I'll talk about what an actor is. We'll go over, not programming languages, but I will go over what they call a use case diagram, which is a very useful concept. Okay. Are there any questions about the UML at this point? No questions? Okay. So we'll go ahead and get started with the concept of an actor. So I'll open this in a new tab. An actor in the UML is basically an active agent that can interact with the system, or okay, that's just interacting with the system. Okay, that's a quote-unquote actor. So in the case of an online bank system, an actor can be customer. Now remember, an actor is not a specific individual, it is a category of people or machines that can interact with this system. So in the case of the Wells Fargo information system, an actor can be end users, customers. Now you can even separate end users into corporate users and individual users, okay, non-corporate users. So that's okay. But an actor can also be a non-human. In other words, an actor can be the information system of the IRS, because the IRS may need to interact with the Wells Fargo bank system to get statements, how much interest each account has accumulated for which social security number and so on and so forth. So the IRS information system, which is outside of the Wells Fargo bank system, also becomes an actor in the picture. Are we doing okay so far? Any agent, anything that can interact with the system that you're designing is an actor. They can initiate actions to the system that you're designing, and they can receive responses from the system as well. Okay? And this is called a use case diagram, and it's really, this is the type of document that you're creating. So you have, the use cases are the bubbles, and then the actors obviously are the metric stick figures. In other words, what you're doing is you're basically outlining what the actors are and how a particular use case can be, what actors can interact in a particular use case. So in this picture, we have a teacher or a parent to maintain question, but this particular use case of the information system has no other actors to interact with. On the other hand, you have a child, okay, in a classroom setting, and a child can play a game, and it does not require any type of interaction. The log-on use case, on the other hand, is shared between a parent user or a teacher user and also a child, because both types of actors require to log into the system. So this shows you, the sharing of use cases between the actors. Are we doing okay so far with this use case diagram? This is called a use case diagram. Each bubble is called a use case, which is one particular use of the system that provides value, a particular value, to the actor. Okay? Any questions? No questions? So the next question that I have is, how do we make pictures like that? On a napkin? You can use just about any software that can draw pictures like that, but there are specific programs designed to deal with the UML. I have one already installed here. It's called, okay, I'm trying to find it. It's already installed, I just need to find it. It's called Gaffer. And you can download it for Windows too. So this is not limited to Linux. You can actually it's open source. You don't have to pay anything. And in fact, I will just go to the website to show you where to find it, and so you can have it installed. It's called Gaffer, and if you just combine Gaffer with UML, you can find the website. It's an open source product. Go to download, and you can go to Windows. It's a Python program, so you have to install Python first. So if you go to the Windows instructions here, so you don't have any real installation option. The best option is to install PyCairo and PyGTK from source, or try one of the installers found here, and then you can install Gaffer using easy install. I guess that's a text file that you can run in the package. Okay. But since I'm using Linux, it's very easy. I just have to say aptitude install Gaffer, and it's done. Most people think using Linux is hard. It's actually very easy, from a certain perspective. All right. So when we get to this picture, we can go to let's see, tools, console. Oh, we can go to here, and we can go to use cases. And as you can see, down here in use cases, you can just drag and drop actors and use cases. So we have an include, relationship, association, and extend. These concepts, we're not going to talk about it in this class. It's by the time you take a object-oriented programming class, you will have better ideas of what those things are. So now we can link this actor to this use case. So it's pretty easy, to use. It's just, what you see is what you get, for drawing pictures. And this one is designed specifically to deal with the UML. So all of the elements that you need in a UML diagram, you don't have to reinvent the wheel. It's all there already. Are there any questions about a use case diagram? No questions? It's a very quick and easy way to describe, what type of category, agents, can interact with the system and how they use the system. And that's basically the purpose of a use case diagram. Any questions? Any questions? All right. You guys don't have any questions about the whole concept of object-oriented, system design? What is object orientation?
How an object is positioned in space.
You're looking from the perspective of quote-unquote objects. That's why it's called object-oriented. Instead of algorithm or logic-oriented. When you do your Scratch homework assignment, it's logic-oriented. It's procedural-oriented, but not object-oriented. All right. Now we also have to deal with database schema. We'll go ahead and take a little overview of this, but we are not going to finish this topic because you have to. There are classes you can take when it comes to designing a database. But basically, this part outlines the information system needs to keep track of what. Why would we call it an information system? It has to keep track of what? Information. All right. And information is usually stored and retrieved by what type of technology? We have gone through this already in the first 3 chapters of the book. A database. Okay, a database. A database is what we use to keep track of data, which is actually the raw form of information, right? So when it comes to databases, the use case, the UML has a particular language to deal with it. It's called a entity relationship diagram, or ER diagram. So when we switch back to here, it's not. Sometimes it's called a class diagram, and it replaces the use of a entity relationship diagram. We are not going to use it in this class, okay? Because it makes no sense whatsoever for this class to talk about this. After you take, I would say CISP 400, you can probably come back to the UML and revisit, classes or a class diagram. Then you will have a much better idea of, oh, so that's what it is, okay? But at this point, we can just kind of let go of this particular component. There are also other ones, actions. These are basically for flow charting, but as I said, I do not really encourage the use of flow charting. Now this is interesting, states. We'll talk about states a little bit. A state diagram, okay, so when you draw these different pictures, you can basically just move it apart, move it out of here, and then you can drag different types of stuff onto the screen. There's no requirement that you can use only certain elements in the screen like this. Okay, a state diagram has what we call a start state. This is called the initial state or start state, and this is called a final state or finished state. Okay, so as the name implies, you start from here and you should end up here. In between, you have these things. You have states, and then you have transitions. Okay, this is called a transition. A transition is nothing more than an arrow going from one state to the next. So you might think, hey, so that's really doing about the same thing as a flow chart, or what we are doing in Scratch, with all the different elements in Scratch. But it's not. It's really quite different. The difference is when you use a state diagram, you are actually describing an object, a single thing. The different states that one single thing can be in. What are we talking about? Let's think about water. Okay, H2O, water. Okay, how many states do you think water can be in? 3 states. Very good. So what we do in this case is, we draw a picture. We have a start state here, and then we have the 3 states, okay? And then we have a final state. In this case, because we cannot create or destroy water, well, we don't want to talk about that part of the science, so we'll just kind of say that water is already in existence. So what are the 3 states? How would you describe or label the 3 states of water? Okay, so we have steam, which is the gas state of water. We have water, which implies it is in the liquid state, and we have ice, which implies it is in the solid state. Okay, what about the transitions? Can we go from steam to water? There's a transition here. What triggers this transition? Condensation. And condensation means the temperature is lowered. Okay, we can just say, temperature changes. Temperature goes down. Okay, that causes condensation. Can we go from water back into steam?
Yes.
And what kind of trigger are we talking about? Temperature going up. All right. So temperature going down is an event. It is also used as a trigger to cause water, or some water, to change from steam to water, or from water back to steam. Does water itself change its own temperature, or is it something external to the system that's causing this to happen? It's external. Okay, so that is one really important part, is most triggers are external to the system that you're describing. Sometimes it can come from the system itself, but most of the time it is considered external to the object that we are dealing with. In this case, the object we're dealing with is basically a cup of water, okay, a certain container of water. So you can complete this picture by using transitions to go between ice and water. Once again, we have temperature change, and you can make this more specific. Okay, what kind of temperature change are we talking about? Are we talking about at 1 atm, which is the pressure? Because at different pressures, water boils at different temperatures. So you can make it more specific if you want to, but nonetheless, it illustrates the concept of what we call a state diagram, because it's basically describing the different states of one particular object, and that's why it's object-oriented. Because now we are looking from the perspective of an object. The object is, a little cup of water. How about between these two, between steam and ice? Can water go from ice to steam directly?
No.
Not
In
under
extreme
1
states.
atm. I think under certain type of pressure conditions it can.
In extreme states, it can jump directly to it.
Yeah, it's called sublimation.
I don't remember where.
Yeah, like dry ice can go from dry ice can go from solid state to gaseous state directly, but you can also increase pressure, so it can actually have liquid state CO2. So that's so that's why I have to specify under 1 atm water cannot go from ice to steam directly. All right, but if we look at this from the perspective of, let's say, Wells Fargo Bank, what do you think are some of the objects that we have to deal with?
Users.
Hmm?
Users.
No, users are actors. We cannot we cannot model the state of an actor because it's external to the system. We can only use this type of picture to model things that are internal to the system. So when you use online banking, what are some of the quote-unquote objects that you have to deal with? Does anyone go ahead?
Authentication.
Authentication. Okay. User account. Okay. User account is certainly one of the objects of an online bank system. So we can now try to look at just a certain small part of a user account. Okay. User account. We use this as an object. So now we have to think about its initial state and also its final state. Okay. So initially, what triggers it to even start to exist? The creation, registration, of a user account. Okay, so we'll just say creation or registration. That's the trigger. Okay, this is called a trigger. Anything that makes the object go from one particular state to the next is called a trigger. Okay. So now we have an account, that is in a particular state. Now, if we just want to model, 3, consecutive logs in and, you're out, okay? How can we model that behavior? Using a state diagram. But first of all, we have to identify all the different states, okay? So what kind of states are we talking about in this case? We have one state of being active, and we probably have another state of being inactive. Okay?
Locked out.
Locked out. Okay, so we'll say locked out. Okay, because of security reasons. Okay. Do we have any intermediate states that we should represent? Probably not. Okay, because even though internally you have a counter, it is not displayed in this picture because, well, if you want to, you can, but it's very tedious. Because if you want to include the counting of failed login in a state diagram, then you have active with 0 failed attempt. And then you have another one with 1 failed attempt, another one for 2 failed attempt, another one for 3 failed attempt, and so on. That makes the picture very, quote unquote, brittle or rigid, because every time you want to change the number of failed attempts, you have to change the picture. So we'll just have, we'll have active, but not include the number of failed attempts as a part of the state. We'll just use it as a trigger. We'll put it into the trigger part instead. Okay. How do we make a transition like this? How do we go from active to locked out?
X amount of failed attempts has been reached.
Okay, that's good. Okay, so X consecutive failed attempts. And how do we go from locked out back to active?
Customer support has been contacted, or
Okay.
issue resolved.
Issue resolved or manual authentication completed. So that will go from locked out back into active. And you might have many other states too, but eventually one state, or it will go to the final state. The final state and the start state, each one has a very specific property. The start state has no incoming errors. In other words, you cannot go back to a start state. The final state has no outgoing errors, which means once you get to the final state, that's it. You cannot get out of the final state. So the final state usually can be you can get into the final state by the deletion of the account.
Or log off. Or maybe log off.
Log off is different. If you want to know whether the account is in session or not, you need a different type of state to indicate it is in session or it's authenticated versus it is not authenticated. It's signed out already. So that's how we look at things from the perspective of an object. It doesn't describe the logic of how to do it. It doesn't give you the flow chart of how to implement the logic. But on the other hand, this is a whole lot easier to read from the perspective of the bankers. Okay, you present a picture like what we did, with Scratch to a banker. They may not understand the logic of even the Scratch program. But when you present a state diagram, and use an example like this first, to describe what it is describing, I think a banker can actually understand a good portion of a state diagram. May not be a very big and complicated one, but a smaller one that only focuses on a few portions, I think they can do it. Okay, and that's why state diagrams are useful, because it doesn't lead to spaghetti coding. It's just describing the behavior of a particular object, how it can go from one state to the next. Okay. Any other questions about a state diagram? No questions? All right. If there are no questions, I think, as promised, I will go back to the Scratch homework assignment and we'll go ahead and describe it or describe the solution. what is the difficult part of this homework assignment? I mean,
testing,
hmm?
bug testing.
Okay, debugging it, testing it, okay. Do you know why it's difficult for you?
Well, I added a couple extra features that
Oh.
allowed the user not to, because it's a number between 1 and 100. So
Okay.
I said it basically tells the user that they can't do a number outside of between 1 and 100, and also
I
they
see.
can't do numbers, or they can't do letters or symbols. So
Okay, so you made it a little bit more difficult by, including error checking. All right, so we'll go to Scratch, and I will open up the homework assignment itself. And so we go to Scratch 1. All right. So according to this program, the first thing we need to do is to use the random operator, which is actually a function, but we'll call it an operator because it's under the operator tab, to pick a number from 1 to 100 and call it the solution. Okay, so that's the first thing I will do. And let's go back to Scratch. I will first create a variable called solution. And then I will start to write the program. When the green flag is clicked, I go to variables, set solution to something, but I don't want to set it to always 0. I go to operators, and I will set it to random, pick random 1 to 100. All right, and I will even test the program. So I go run the program. The first random number is 28, 21, 58, 27, and so on. So that part seems to be working. Time to continue with the rest of the program. Ask the user for a guess. Okay, fine, I'll do that. So I know I'm not writing the program, from beginning to end, in one swoop. I'm doing in steps. So I will go to sensing, ask, and say, give me a guess, and wait. And then I go to variables again, make another variable. I make this one, guess. And I will remember the answer to the guess and go back to sensing and then drag answer to the right hand side. I run the program again. It gives me another random number, and then I will go 65 or 60, 65. It remembers the guess is 65, and that's it. The program is supposed to work only up to this point. So it's working, as expected. Now, it's a very simple program, but still, I want to double check and make sure that it does work the way it's supposed to. If the guess is greater than the solution, indicate so. Okay, so the if here, the word if implies it is a conditional statement. So I have to go to go to Scratch and go to control and get a conditional statement. Now, remember, I always use if-else. Even though there's only one action to take, I always use if-else just in case later on I have something to do for the else. So in this case, I only want to check if it is greater, because according to the homework assignment, the first case I want to check is whether the guess is greater than the solution. To check whether something is greater is an operator. This is greater than. And according to this, I'm comparing the guess to the solution. Go back to variables. Go to guess and solution, and according to this, I would use either say or think to say that the guess is greater than the solution. So I go to looks, and I'll just use say for 2 seconds, and I'll just say exactly that. Okay, the guess is greater than the solution. And I can test the program right now, so I can run it, because I can actually see the solution. The solution is 86, so in order to test this logic, I have to make my guess greater than 86. 99 will work fine. So I enter 99, and Scratch says the guess is greater than the solution. It's working up to this point. So you can see that I'm constructing the solution step by step. I'm not, saying, oh, okay, let's put a loop in here and stuff like that. I'm just working on this, step by step. This is one unique advantage of Scratch. It allows you to prototype or write very simple code, test it, and then write some more, and then test it again. It's called rapid prototyping. It allows you to do that sort of thing very easily and conveniently. With C and C++, when you take cisc360, it's not as convenient. You can still do it. It's not troublesome. It's not like in the mainframe days. You have to submit another pile of punch cards and get the results the next day. Okay, that would be very inconvenient. Okay, every time you make a little change, you have to wait a day to get the results. And that's also back when the programmers are actually smarter, because they have to be. I wouldn't call them smarter, but I would say they work smarter. Okay, so as people, they may not be any smarter than you guys, but they have to work smarter, because they cannot just say, oh, I'll make one little change in my program and test it again. That approach was not feasible. They just could not do it. But today, with the tools that we have, we can do it more interactively. All right, so that part is done. Now, the really tricky part is, how do we do this part here? For this program, there are two solutions, and I will take both as correct answers. Okay. The guess is less than the solution and indicate so using say or think. So one thing we can do is to basically replicate this block here. So I'll just duplicate it and stick it here. And instead of using greater than, there are two ways to fix it. I can just exchange solution with guess and change the text here. And we're done, right? That's one way to do it. The other way to do it without changing actually the behavior of the program in this case is to put this block within the else. That is actually a better way to do it, because the guess is greater than the solution and the solution is greater than the guess cannot both be true at the same time. They're exclusive to each other. So that means if the guess is greater than solution is false, we should then check whether the solution is greater than the guess. Okay? But in this class, I'll accept both solutions. So if you have the other conditional statement consecutive, like next to the first one, that's fine. Okay, I'm not going to take any points off. Go back to step 2 if the guess does not equal to the solution. Oh, okay. I don't have any way to go back now because these are all just conditional statements. In order to go back, I need a different construct. What I need is a repeat until construct, because this is the only way I can actually go back to an earlier step. But what do I need to do repetitively? What do I have to do over and over again? Asking the question to giving the hint, right? So I have to take everything from here inside the repeat block and then make that entire block here. Okay, so this is the critical step. This is the critical step of saying, okay, now I know how to do it once. How do I make it do it over and over and over again? And from which step do I want to do over and over again, and ending at which step? That's the critical concept, and say, oh, okay, this chunk of code I need to be doing again and again, and so I need to put it inside a repeat until construct. Are there any questions about this part? Because I would say this part is probably the key to this homework assignment. But when you have a repeat until, you also have to specify when do we get out of the loop and stop asking those questions. I guess when guess equals to solution, okay. So then you go to operator, go for the equality, and say when guess equals to solution, we get out of the loop. When you get out of the loop, you just have to go say something else here and say you got it, which is bad grammar, but it's okay.
It's a cat, so it's supposed to be talking.
It's a cat, so it's just say meow, 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 meow. Yep. Actually, some cats can talk. In Pokemon. Only one cat can talk in Pokemon. It's only Meowth. Only the Meowth of Team Rocket. The other Meowth cannot talk. With an accent. Okay, so All right, so this program seems to be finished, but it's really not finished yet.
Don't you need to initialize the guess?
Yep, you have to initialize guess because otherwise there is a possibility that it will not get into the loop even once. So you got to make sure the initial guess is not equal to the solution because there's always a chance that from the last time you played the game, you have a number already in guess and it turned out to be the same as the solution of the next round. Then it won't even get into the loop and say, oh, you got it. Well, but that's not how the game is supposed to be played.
Good idea.
So you need to have one more thing here. Basically, the idea is, before you refer to any variable, you should initialize it first. So in this case, before we use, guess, now solution is already initialized here, but not guess. So we'll go to variables, and then we'll set guess to a number that cannot be a part of this number. Setting it to 0 works just fine. Okay, so now the program is done. We'll go ahead and check it. So this way, I know the solution already, so I can actually test the program this way. We'll start with a number that is less than 9. The guess is less than the solution. Good. We'll work with something that's greater than. The guess is greater than the solution. That's good. And then we'll go ahead and give it the correct number, which is 9. And you got it. And you should finish. Now, to make this game more entertaining, when you're testing it, you can actually turn off these things. So you basically just uncheck it so that it won't display the value when you're running the program. So that makes it more fun, right? Because you don't know exactly what the number is. So I will start with the middle part, which is 50. The guess is greater, so the next number is 75. It's greater than the solution.
So you need to do
Oh, I was moving in the opposite direction.
Yeah.
Okay, so we're 25. The guess is still greater than the solution, so next one is 12. The guess is less. Okay, so 12 plus 25 divided by 2, 18, 16 or so. The guess is greater.
15, 12, or something like that.
14 and 15 are the same.
16.
I'm
still wrong.
17.
So it has to be 17. You got it. All right. So that makes the game a little bit more interesting, okay? So for the next homework assignment, I want the hangman game.
Making hangman.
I'm just kidding. No, that would be appropriate for the next class, for the cisc310 class.
Actually sound like-
That would be appropriate, okay, as a final project too. Not a homework assignment, but as a project, because hangman is actually very complicated when it comes to specifying logic in tiny little pieces like that. Okay. Wow. Okay, so we got the program done. We got it tested. We have a pretty good feeling that this is working, correctly, the way it's supposed to. So that's how it's done. What is the difficult part about this homework assignment? I know some of you really enjoyed it and didn't find it difficult. So for people who find it difficult, what is the difficulty of this homework assignment? Now, I know it has nothing to do with remembering or memorizing what statements you can use because they're all listed in the different tabs. Okay, so a traditional programming language like C and C++, the first difficulty is to deal with the syntax of the language. All those specific rules. Here you need a semicolon, but here you don't want a semicolon. You can only use round parentheses here, you can only use square brackets here, you can only use curly braces here, and so on and so forth. Those things are, it takes time to get used to them, but in Scratch, it's not it's not a big issue. So what is the difficulty of this homework assignment? We have all the blocks. The shapes of the block imply where they can go. So that takes the place of syntax checking. So the difficult part is what?
Probably remembering where to do the loop to make sure it repeats.
Okay, because that's one of the elements, but you have to remember what the element mean. In the grand scheme of things. So that's one. But there are only so many elements. So once you get used to programming, it's not a big issue. The biggest difficulty is where to put what. Okay, you can identify all the different blocks that you need. You know what comparison you need to do. You also need conditional statements. You know about loops. the question is, how do we put those things in a specific order to do what it is supposed to do? That's one of the challenges of programming. And the second thing has to do with, we are specifying things in very small, quantities. Like, every step is only doing a very small thing. I mean, it's very, it cannot do a whole lot. And then you have to construct bigger blocks and bigger blocks in order to do more and more. Okay? There's a lot of details you have to deal with. Okay? So programming definitely has a lot of, it's very detail oriented. Okay? And that's all really good because it goes all the way back to systems analysis. So let me go back to, where's my Moodle page?
You had it all the way over there.
Oh, okay.
All right.
Right there. Okay, so let's go back to topic. Yep, go ahead.
When do you think our next Scratch homework assignment will be?
I'll probably give you a new homework assignment, today, later today, so that you guys can, have a little bit more practice with Scratch, and then there will be another homework on the UML because I think that's also very important. All right, so let's go back to topic 7 and topic 6. We'll deal with topic 7 and continue the discussion of building a house, okay, or the equivalence of building a house. So the next question is, okay, the first thing I want to talk about is in building a house, the architect and the engineer are two different parties. Okay, in other words, you have one firm or one party being the architect, but you need to hire the engineer as a separate party. Okay, they're not the same person or the same company. In systems analysis, it is the same person. So a systems analyst is acting both as an architect and also as an engineer, handling both the design perspective and also the technical perspective. Okay? You might have some other people who can only do design later on to design the pages, how do you want to present the online statements and stuff like that. You might have a separate person doing that later on, but in terms of what type of information should be on that screen, the system analyst will determine that. Okay. All right. So the systems analyst is combining the jobs of an architect from the design perspective, as well as the perspective of an engineer, making sure the system is feasible. It can actually be implemented, without exceeding the budget set by the client. All right. So let's just say the systems analyst is all done, with the analysis and come up with a blueprint, which is in the UML or some other languages, and describe the full specification of the system. What do we do next? We need developers, okay, the contractors, okay? Now here comes a big, huge question. How come the system analyst is not going to also do the implementation, which is, developing the program and, actually building the house, so to speak?
Because he only knows how to design it from a perspective that other people can understand, like the UML, but he doesn't actually know how to specifically build it.
Okay.
So to speak.
Now this is where things get a little bit muddy, okay? Because when a systems analyst is the person who creates the entire blueprint, the full specification of the system, he or she certainly knows enough about the system to implement it, to actually turn it into actual C++ code or Java code or Perl, PHP, or whatever programming language that the system is supposed to be implemented in. So the question is, why don't we let the systems analyst also perform that particular function? Or why is it not a good idea?
Because if there's anything wrong with it or any weaknesses in the design, then it's less likely to be noticed unless somebody from the outside does it.
The systems the developers would not assess the system for security. There's actually another person or another party. If you want to make sure the system is secure, there will be an auditor for security, system security. So that's not the exact reason. Okay, so let's think about the live from 9 to 5. Okay, what do you think a systems analyst has to do? Remember, the systems analyst is the person who's interacting with the client. Okay. And what do you think will usually happen when you have to interact with the client? You have phone calls, you have meetings, you got email that you have to respond to quickly. There's a lot of interaction with people in the job of as a systems analyst. The systems analyst is also in charge of the document, the big, huge document that we call system specifications. So he or she has to spend a lot of time, editing the document, keeping track of the revisions, and doing all sorts of things. So that person may not have the time to do programming. Okay, because programming requires a lot of kind of unique thing. One, as a programmer or as a developer, you don't want to be disturbed. You don't want phone calls or meetings. You just want to be left alone for 8 hours or so to do your coding. Okay, how many people have coded or written programs before? Not a whole lot. Okay, would you like to be disturbed, like once in a while people call you, the client calls you and say, oh, you know what, I want to change the specification, blah blah blah. Okay, or oh, it's time for a meeting. Okay. It doesn't work out that way. Why doesn't it work out that way? Certain occupations, it's okay to have meetings and interruptions. But why do you think programming, is not one of those occupations?
It takes concentrate though.
I was gonna say it's very easy to like lose track of where you were.
And do you know why it's easy to lose track? It's because when you write a program, there's a lot of details. Okay, so your mind, most people can only keep track of about 7 concepts at a time. Okay, they say 7 numbers or 7 digits, but it's actually 7 objects, 7 things that you can track at any particular time. When you are programming, you are tracking more than 7. So you're already straining your mind to keep track of all the details, greater than, less than, all the variables, all the subroutines, all the calling conventions and whatnot. By the time you get to cisc310 and 400, you will understand what I mean. But your mind is already busy with all you're already pre-filling your mind with all of these details already. A phone call is going to, it's just, it's like a shotgun, right? All that stuff that you have already been tracking in your mind, half of it is gone after the conversation. Okay, and then what do you have to do? You have to re-establish the context of where you left off in programming in order to continue the programming. And that's why, when you are developing program or coding, the interruptions are really, really bad. I mean, and that's why your programmers work, well into like 7 p.m. or 8 p.m. and everybody is gone. The programmers are still at the company, drinking Mountain Dew and eating cold pizza. Because Mountain Dew, has sugar and caffeine, and cold pizza, it's just, it just tastes good. Okay?
Yeah.
The cold part, the programmers don't notice whatsoever, because their mind is so focused, on programming.
That's where you disconnect all the phones and everything.
Sorry?
That's why you disconnect all the phones and everything, so you don't get no phone calls or anything.
Go to a silence.
Exactly. You have to you have to submerge, basically. Just forget about everything else. And that's one big reason why a systems analyst does not make a good developer. Simply because a systems analyst has to be available all the time. Okay, the client calls up, and the systems analyst has to answer the call, and potentially make changes to the document or propose changes to the document and stuff like that. Whereas a programmer, needs needs a long block of time and say, okay, I don't want anyone to tell me that the program has changed or the specification has changed. I don't want to answer any calls. I don't want to deal with anything, bug reports or whatsoever. I just want to get this part of the program done. Okay. On the other hand, a person who makes a good programmer may not make a good systems analyst. Okay. Why do you think that is the case?
Antisocial.
Antisocial, because that make them good programmers to begin with, right?
Yeah.
So because being antisocial means they have fewer distractions in life to begin with. Okay, but there are other things too. As a programmer has to keep track of programming languages, the syntax of programming languages, has to keep updated, about all these new standards, because PHP 5.8 is not backward compatible with PHP 5.7. So now you have to keep track of all of those incompatible changes and make sure that the program keeps working. So a lot of technical stuff, you have to keep track of, when you are a developer. Okay, it doesn't leave you a whole lot of time to, answer customer calls and stuff like that. So that's why, there's the separation. In real life, when you're building a house, it's the same thing. Why don't you hire your engineer and your architect to be your contractors? Well, first of all, some people complain, well, they're a lot more expensive. The hourly charge is a lot more. But let's just say that you have an infinite budget, so you can actually hire your architect and your engineer as a contractor. Would you?
No.
No, most people won't because your architect and your engineer, they work with calculators, they work with paper, they work with computers really well. Would you trust them with a hammer or a screwdriver?
Themselves.
Then
They
would you
hurt
trust them
themselves.
with a circular saw or table saw, bigger, more dangerous items? I would
Use
not.
hammer.
I would not. I mean, even if they agree to build your house won't be built in 3 years. Because it will take them a lot longer. So that's why we have specialization, and that's why developers are developers. Okay, after the contractors build a house, after the developers actually write the programs, what comes next?
Manufacturing.
Not yet. We're skipping one step. After you got your house built by the contractors, inspection. Very good. So why don't we have the contractors do their own self-inspection?
They just pass
They
it.
might not tell you what's wrong with
Yeah.
it.
Okay, but let's make the assumption, a bold assumption, that the contractors that you hire are 100% honest. They're perfectly honest people.
Most people don't understand their own mistakes. Someone has to point it out.
Exactly. Well, it's a chicken and egg kind of thing, right? If the contractor or the developer understood the specification correctly in the first place, they would have implemented it correctly in the first place. So the fact that there's a defect in the code, sometimes it's just accidental, okay, so it's a typo or something like that. But most of the time, it is not. Most of the time, a bug or a deviance from, a bug is basically a defect or a deviance from the specified behavior. That usually is because of a misunderstanding on the part of a developer, or something is vague in the system's specification, and it could be interpreted either way. So if you rely on the same person who read the specification and wrote the code to inspect the program, the chances are that problem would not be spotted. So you need somebody who did not even look at the source code, who do not have access to the source code, which is the base of the program itself, to test the program against the system specification. And that's why you need someone who is completely separate from a developer to do the testing or quality assurance, QA. Okay? So QA for software is called, those people are called test engineers. It sounds like a really big title, instead of a tester or, test lackey and stuff like that. It's a test engineer. And that's because testing can be more difficult than developing. Can anyone kind of think why testing can be more difficult than developing? Okay, go ahead.
We'll go there. Oh, because just to forget what I was going to say. Because it's easier to go in one direction than to always be looking back to make sure you don't accidentally skip something.
Okay. And you raise your hand too. Everybody, nothing? Okay, go ahead. Oh, the possibilities, very good. You can write 5 lines of code, but how do you make sure that those 5 lines of code will work for millions of possible test cases? That's the question. Okay? If you just look at, let me switch back to the Scratch program to illustrate it. If you just look at this statement here, if guess is greater than solution, blah, blah, blah. Well, it looks really simple, but how do you know it works for all possible cases? How many possible cases are we talking about?
Any number that's that you give it.
We're talking about 2 to the power of 64. That's the number of possible cases. Now, in this case, obviously, it's a simple thing. We can see that we only have to test it with 3 possible cases, greater than, less than, equal to, and we're done with it. But with the more complex programs, it's the possibility that is the issue. Okay, how do you know that you have tested every single case according to the specifications? That's the question. And that's why when it comes to testing, it's not a simple thing. It's not just manual labor. It has to do with the analysis of the specification of the system and also working with tools so that you can retest and retest and retest consistently. It's called regression testing. Okay? Do you think someone, okay, in the case of the Wells Fargo Bank online system, obviously they have some sort of QA in place already, because otherwise it's very dangerous. Do you think someone actually go in, go through like 2,000 pages of test procedure and manually go in and go click, 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 put in a number, okay, that works, that works? No. Testing is automated. Okay? In other words, the test engineers would actually write their own programs to generate test cases to test another system. And that's why their job is actually, in a way, more difficult than the jobs of the developers. Because who's going to test the program written by the test engineers? It's test engineer squared, right? It's the test engineer who tests the output, the programs of the test engineers. So the test engineers really have the last responsibility to make sure that anything that passes that gate has the quality, to pass the gate. And that's why testing is actually very important. And a lot of times those people are under a lot of pressure too, because if anything did, if any bug of the system did go through, do you think the programmers will be blamed or the developers? No. The systems analyst? No. It's going to be the test engineers. The quality control team is going to be the people who have to take the responsibility when something bad happens in the field. Okay, so their job, is actually, there's a lot of pressure in that kind of a job. And some people like it and some people don't like it, depend, that's a personal kind of thing. Okay, and we are running out of time. In terms of maintenance, those people are called system administrators. We can talk about that next time. All right, I'll see you guys next week. Have a nice weekend. It's a long weekend, but I'll see you guys on Tuesday.
What about the homework?
I'll post it.
Mr. Tech, for homework, how do we check the grades?
You check your grade